if we have a specific number for a, like 2 to the x, and we want to know what is the line tangent to this function at the point, let's say 2, 4. So the slope would be 2 to the x times natural log of 2. That looks kind of weird. There we go. And at the point where x is 2, f prime of 2 would be 2 squared times the natural log of 2, or 4 times the natural log of 2. And that's our slope, and so our equation would be y minus 4 equals 4 times the natural log of 2 times x minus 2. And that's the line that we would have that would be tangent to that equation. For this last little bit, I'd like to look at the function a to the x. And earlier in an earlier section, when we had this exponential function, we got that f prime of x was a to the x times some number, and that number was controlling the vertical stretch or shrink. And using the definition of the derivative, we got that this some number was the limit of a to the h minus 1 over h as h goes to 0. But today, my friends, I'm going to show you a quicker way to get that number, what that limit is equal to. Okay, it comes from the fact that if we have a, we can write it as e to some power. I don't know what that power is, but really any number a, we can write it as any number, any positive number anyway, to a power. In the same way that you can write 100 is equal to 10 squared, or 100 is 100 to the first power. You could, or 100 is 10,000 to the 1/2 power. You can write any number as a power of any other positive number. Okay, so a is e to some number, and the way we find that some number is we use logarithms. And so we can rewrite this statement using logarithms to say that the exponent, question mark, is equal to the logarithm base e of a. So with this up here, we could say that the exponent 2 is the log base 10 of 100. Logarithm means exponent, and so the exponent on e is question mark. That would give us a. And log base e, we have a special symbol for that. It's ln, for the natural logarithm of a. So that question mark is really ln a. So a is equal to e to the natural log of a. So if I go back and think about this question about f of x equals a to the x, and I wonder about what's the derivative, a to the x, I could rewrite it as e to the natural log of a to the x. And then I can use properties of exponents. So if I were to take like x squared to the 5th power, that would be x to the 10th power. I would multiply the 2 and the 5. So here I would multiply the natural log of a and the x and get e to the natural log of a times x. And I can think about this using the quotient, or no, I'm sorry, the chain rule. The inside function, or u, would be the natural log of a times x, and the outside function would be e to the u. And then my derivative would be e to the u of the outside function. And the inside function is a number times x, so its derivative is just that number. And so f prime of x would be e to the u times natural log of a. But to get it out of terms of u and in terms of x, it would be e to the natural log of a times x. times the natural log of a. But e to the natural log of a was another way of saying a. So really we get a to the x times the natural log of a. So that some number is really the natural log of a. This would be a great thing to put on your list of functions and derivatives. So if it's a to the x, the derivative is a to the x times the natural log of a. On Monday in class, we'll go through some applications of using the chain rule.